This is the brief on the visual geometry of the Jacobian determinant in coordinate systems. So, when you use different coordinate systems like hyperbolic or parabolic, well, they actually end up stretching or compressing space. The source material shows how we can visualize this, using something called the Jacobian determinant to see exactly where all that stretching and squishing is happening. First, what's the role of this Jacobian thing anyway? Well, think of its absolute value as a stretch factor. The way we see it is with color. Where it's brighter, space is being stretched more. This factor is the crucial number you have to multiply by to get back to the true area on a normal grid. Second, let's look at the hyperbolic system. For this one, the Jacobian factor is just 2 times the absolute value of v. Simple, right? And what that means is the stretching increases nice and steadily, linearly, as you move out from the center. And the key thing, the most intense stretching happens right along those main x1 and x2 axes. Finally, let's switch gears to the parabolic system. Its Jacobian factor is t squared plus s squared, and that changes the whole game. Because you're adding squares, the stretching is basically 0 only at the dead center. From there, it just explodes outwards, quadratically in every single direction, creating this really symmetric pattern. So when you put these two right next to each other, that simple linear stretch versus the explosive quadratic growth, you can instantly see just how fundamentally different these two systems really are at warping space.